And here we go. Today we're going to investigate the side-side angle situation. You guys remember from geometry that side-side angle is bad, right? But why is it bad? And the deal is you can't create triangle congruence because there's more than one possible triangle. I'd like to show you how this works. Side-side angle, we're going to investigate a situation where the opposite leg is shorter than the other given side. I want you to draw a triangle that looks about like this. You'll see why I drew the dotted line here in a second. When you look at that triangle, can you convince yourself that that is a side-side angle triangle? Okay. And that it looks reasonable, 35 degrees, 10, and 8. Everybody agree that looks within reason? Okay. Now, here's the problem, and here's why we can't use side-side angle as a congruence theorem. Because that's one triangle that makes side 10, 8, and 35 degrees. And then here's another one. Watch as I take this leg. If I keep a position of 8 and I kind of just swing it on a pendulum and it comes up on the other side over here, wouldn't you agree that that is also a triangle of side 8, 10, and 35? I mean, you can actually see it kind of burned in over here. I mean, those are kind of same side lengths. It's like, you know, which one is it, right? Which one is it? Is it this one? Or is it this one? And that's why you can't use side-side angle as a congruence theorem, because there are two solutions. You're not going to understand everything from when we first talk about in these first 4 minutes, but I want to try to give you some depth of understanding here of why this works out the way it does. Suppose we were to solve for this angle C right here. The first thing I want to do is just have you understand this angle right here. Is it acute or obtuse? Obtuse. And then this angle over here, is that acute or obtuse? Acute. Interesting. One of the triangles has an acute angle in that position. The other one has an obtuse. I wonder why. You will see why, and watch. If we were to solve for angle C, we would take sine of what over what? 35 over 8. Way to go. So now, if I wanted to solve for sine of C, what would I do to both sides? Multiply by 10, and I would get 10 sine of 35 over 8 is equal to sine of C. Everybody with me? I mean, this is what we practiced yesterday, right? So let's go to work. I'm going to go ahead and figure out what I get. And I have 10 sine of 35 divided by 8 is equal to 0.71697. 0.7169705. We'll just stop there, okay? All right? Am I solving for an angle or am I solving for a side? An angle. So what would you do to solve for the angle? Inverse. Now right now you guys are like, Mr. Gens, I don't get the big deal because I know how to do this whole problem. Uh-oh. I pressed sine of that. That was really bad. We'll go sine inverse of 0.7169705. And I get 45.8. Is that the acute or the obtuse? It's the acute. The acute angle is 45.805. Here's the problem, folks. Is the value of sine positive or negative? It's positive. In which quadrants is sine positive? Do you remember? 1 and 2. Do you get acute angles or obtuse angles in the first quadrant? You get acute. Do you get acute or obtuse angles in the second quadrant? Obtuse. Watch this. If I take 180 and I subtract that angle, I get 134.195, which would be this angle right here. And to prove it to you, watch what I'm going to do. If I take the sine of 45.08 or 0.805, what should I get? Hint, it's somewhere on the board. You should get 0.7169. Everybody agree? If I take the sine of that, I should get that. Turns out that if you also take the sine of 134.195, you get the same value. You see, when you go to inverse this value, it doesn't know. Do you want the angle in the first quadrant or do you want the angle in the second quadrant? Because sine is positive in both. In fact, both have the same reference angle, 45.805, 45.805. And that's why we have to create two triangles. Now, your ability to solve that right now, you're like, oh, I can't do that on my own. And that's fine. Towards the end of the lesson, you'll do it, and you'll totally understand it. Can we go to the easier one? You will have two triangles. You don't have to draw anything right now. Let's look at this situation. Suppose we had this. Side length 10, angle of 35 degrees, and I'm going to go a side length of 2. William, why don't you tell me when you think I have about a side length of 2? If that's 10, is that 2? Longer or shorter? Okay, you think that's 2? All right. Okay, so can this make a triangle? Why?
Yes, it could. It could make a triangle.
It's just stretch. No, it's too short. Just won't make it, right? It's like you want to dunk a basketball and you can't. You're just too short. See what I'm saying? Just can't make it. Sorry. So sometimes you can have a side opposite the angle is shorter than the other given side and there's no solution. I'll show you why. Let's set it up. Sine of 35 divided by what? 2 is equal to the sine of C divided by what? 10. If you were going to solve that, what would you do to both sides? So 10 sine of 35 divided by 2. Take out my calculator, and I'm going to go 10 sine of 35, and I'm going to divide it by 2. I get 2.86. Before we even inverse, you just took a test on the graph of sine and cosine, didn't you? Think of sine of x. What's the biggest that graph can be? 1. What's the smallest it can be? -1. Sine goes between 1 and -1, right? Can it get all the way up to 2.86? No way. So if you try to sine inverse that answer, come on, sine inverse. What's going on, folks? Okay, sine inverse, and if we take the answer there, notice we have an error. And so in that situation, no solution. And that's all you have to write. Bigger than 1, no solution right away. This is when you know, not by just looking at the picture, when you come up with a sine value greater than 1. All right. Suppose you get an opposite leg that is longer than the other given side. So in this situation, I still have another side-side angle. Let's see what happens when I try to put this one on a pendulum and swing it on over to the other side. And take this leg. If I swing on over to the other side, does it make another triangle? No. If it's longer than the other given side, then it's not going to swing over to it. Now look at what we did before. We had it here, and we swung it to here. So there were two triangles in that situation. But when it's longer than the other given side, then it's not going to work. So in that situation, there's always just one solution. So our goal today is to look at the three possible outcomes of the side-side angle situation and be able to deal with them. Let's get started, and I encourage you to have this sheet. No, not that sheet. Let's try that again. This is, no, we're still, this is in your notes. Nope, we're not moving to the homework yet. You could rip it off and then restaple it. Okay, then you could just follow along on the board. Okay, so I'm going to go ahead and bring that back up. Where is it? Right here. Here I am. So I'm going to solve these triangles. Yes. Thank you. A, B, and C. I've got A is 42 degrees. Side A is 22, and side B is 12. So, is this a side-side angle triangle? Yep, it is. So what I do is I go to my decision tree. It says side-side angle. I go down here, and it says, is the side opposite the angle longer than the other given side, or is the side opposite the angle shorter than the other given side? Let's check it out. The side opposite the angle given, is that longer or shorter than the other given side? It's longer. And so therefore, if it's longer, you can with confidence say there is exactly one solution using the law of sines. So what we are doing right now is a complete recap of what you did yesterday. This is to check to make sure that you know what happened in yesterday's lesson. I go ahead and write down 42 degrees for angle A. 12 for side B, and 22 for side A. So, tell me how you solved this kind of a problem yesterday. What did you do? Good. Sine of 42 over 22 is equal to the sine of B over 12. What did we do to both sides? Multiplied by 12. So I'll multiply the 12 over, and I'll get 12 sine of 42 divided by 22. And I've got 0.3649. Am I solving for an angle or a side? Angle. So as Sydney said, because I'm solving for an angle, I will sine inverse in order to get my angle, which is 21.41 degrees. Go ahead, between you and your partner, anybody around you, see if you can find angle C and side C on your own now. Go. It does not work because you're not in a right triangle. All right, somebody, angle C. And side C? 29 point. Any questions there? Going once, twice, 3 times. Great. Let's move on to the next one. True or false? This is a side-side angle triangle. True, it is. So I go to my decision tree. Is the side opposite the angle longer or shorter than the other given side? It is shorter than the other given side. And so because it's shorter, notice where I'm at. Shorter than the other given side, it's either no solution or it's two solutions. So right now, here's what we know. There's no way that there is simply one solution here. It's either none or it's two. We don't know until we set it up. Let's set it up. Sine of what over what? So I'll multiply both sides by 25. 25 times the sine of 85 divided by 15. And I get 1.66. Can sine be a value of 1.66? No. Notice what the decision tree says. It says when solving for the missing angle, if sine is greater than 1, then there are no solutions. See that? So in this situation, we can see that there is definitely no solution. So in my triangle, the geometry of it all is that this 15, it's way too, wait a minute, should be drawn the other way actually, but we can do it. This 15, there's no way that it could stretch or reach all the way over to side B, or point B. There's no way. It's too short of a side. That's what we found out. Okay. So we do our last one. I have angle A, which is 20.5 degrees, angle B, and angle C. I have 31, and I have 12. Looks like another donkey situation, huh? Yeah, I've got this side-side angle triangle, and so I go straight back to my decision tree. Is a side opposite the angle longer or shorter? It's shorter, so I either have one solution or two solutions, or I have no solutions. So this is what we're going to have to figure out. Do we have one or two solutions or no solutions? And we're going to figure this out by setting up the law of sines. Sine of what over what? Is equal to? Multiply both sides by 31, sine of 20.5, and I divide that by 12. I get 0.9047 is equal to the sine of B. Can it be 0.9047? It can. What does the decision tree say? It says when solving for the missing angle, if sine is less than 1, then there are two possible solutions. At this point, set up two triangle solutions. So that's what I'm going to do. I got to set up two solutions, not one. Triangle 1, triangle 2. A, B, C, A, B, C. You're not going to draw the triangle, you're just going to find the solutions. What I know about these two triangles is they both have an angle A of 20.5 degrees. What else do I know about this triangle? Side A is equal to 12. Thank you, Miss Avery. And side B is 31. That's what I know that these two share in common. The other things they do not share in common, okay? The other angles, the other sides will be different. Which angle am I solving for right here? B. So in order to come up with angle B, what do you think I do? I inverse, just like we would normally do. And I'm going to go to, because I made another error, so second sine inverse of the answer, and I get 64.78 degrees. Doesn't matter, just put it with one of them. Yes, so let's talk about what Easton just did there. It says, at this point, set up the two possible triangles. triangle 1 will have the angle be an acute angle. Did we come up with an acute or an obtuse? Acute. And we found that. To find the obtuse angle, simply take 180 minus the angle. So I want to come up with the other angle that's sitting over here. In order to do that, I do 180 minus that answer, and I get 115.22. So that's what tie those two together. Now you can solve for angle C and side C separately for each one. So what I'm going to do is I'm going to take you guys right here, along with you guys, you're going to find angle C and side C for triangle 1, and then you guys and you guys right here, you're going to find angle C and side C for triangle 2. Just simply subtract and then use your law of sines. Ready, set, go. All right, let's see where you're at. Over here, what did you guys get for angle C? 94.72? Okay, and what did you get for side C? Okay, and what did you get for angle C here? And what did you get for side C? So I like that because it should be between 12 and 31 because that's the middle angle, and it is. And then here it's the biggest angle, so that should be the biggest side. So I like what I'm seeing there. Any questions on that? Okay, then just to kind of round out our understanding, we're not going to solve these, we're just going to draw them out, and you're going to have a chance to, this was a good exercise I did last hour. I'm going to look at 105 degrees. And side B is 20, and then side A, we're not going to call it 4, we're going to call it 19. 19. So, hint, you don't have to use your calculator at all, and you should be able to look at this and determine, without using your calculator at all, whether it's one solution, two solutions, or zero solutions. And when I say you should, I don't expect that everybody will. There's something here that you maybe don't see yet, but have a 30-second conversation with those around you. Decide if you think that there's one, two, or none. Go. One. Okay, is there anybody who's really confident about whether or not this is 0, 1, or 2? Why?
Because 105 is going to be the biggest angle, yet the side is 19, but the other side is bigger than that side, but the angle is smaller.
So why does this have to be the biggest angle?
Because you can't fit like another 106, say 106. You can't fit that into a triangle.
Sydney is 100% correct. Does everybody agree that this is the largest angle of the triangle? There's no way you could have two obtuse angles. Okay, so therefore, this is an impossible triangle. There's no way that could be 19, that would be 20. This would have to be greater than 20, wouldn't it? Here's the problem. Watch, this is the problem. When you do the sine, if you don't recognize that, you did the sine of 105 divided by 19 is equal to sine of B over 20. Here's the problem. When you type in sine of 105 in your calculator, it happens to be the same as the sine of 75. If that was a 75-degree angle now, is it possible? It is. Your calculator doesn't know the difference between these two. I'll prove it to you. Watch. I turn my calculator on, and I go sine of 105. I press enter. I press sine of 75. I press enter. And it's the same stinking thing. Your because of this. Don't you remember? If you have a 30-degree angle there, what is that terminal point, folks? And tell me, is sine the x value or the y value? It's the y value. Now, I'm going to draw it over here. Now, this is 150 degrees now, isn't it? That's an obtuse angle. What's the terminal point there? So look, the x value changed, but the y value stayed the same. It doesn't know the difference between acute or obtuse. It doesn't know. I love that there's geometry and our previous trig, like it all comes together here. To me, that's the power of mathematics. It's the connections. And part of what and I'll let you work. Yes. That's what my wife says. It's kind of a fight in the family. Don't. She's your child, you know. All right. Decide. One solution, two solutions, or no solutions. Go. What do you think? There is one. And the reason why is this. Is 152 degrees the largest angle? It is. Is it opposite the largest side? It is. And so our side-side angle says if the side opposite the largest or side opposite the angle is longer than the other given side, then we can trust that there's just one solution. There's one solution here. Take out your worksheet. No. No, there's no proofs in this unit. I did a proof for you just the other day. Until you multiply and see if you get a value bigger than 1 or less than 1. All right, on your worksheet, if you want to do 1 and 2, you can, but you don't have to. But you do have to do the other 6. And I'm telling you right now, out of the 6 problems that you have, okay, out of the 6 problems that you have, 2 of them are 1 solution, 2 of them are no solution, and 2 of them are 2 solution.
So there's 2 of each?
So there's 2 of each.
Why did you just say that? Because it's more dramatic to say it the way you did say it. I have a question.
Roll it. Let me have my fun. You do not have to find the area, but we will find the area on Monday because tomorrow we don't have this class, but I do have it 3rd hour. So what am I doing tomorrow in my 3rd hour class? We're just going to show them like a 5 minutes of finding the area. Liv? Okay. All right. So I'm going to answer Trey's question, then Olivia's. Go ahead. You can probably at least get 2 of them done. You got 10 minutes here.